Okay, Precalculus, let's go over our Unit 3, Lesson 5 formative assessment. Material is starting to get just a little bit more difficult, and I'm just realized that you guys can hear me tapping with my pen on there, which is super annoying, and I don't know how I can fix that. Let's go ahead. There are different ways to do these problems, but I'll just pull out the first one that I can see as I was doing the problems. So if I take a look at this first one, this is definitely going to be first thing I see is I can do sum. So that's going to be, I need two numbers that when I add together I get 13 pi over 12. So I'm going to use 4 pi over 12 and 9 pi over 12 because when they simplify I end up with pi over 3 and 3 pi over 4, and both of those values are on the number line. So if I do using the formula for sum of cosine, I get pi cosine of pi over 3 times the cosine of 3 pi over 4. Shoot, I'm going to run out of room. Minus, the sign is opposite for cosine, cosine, sine, sine. Sine of pi over 3 times the sine of 3 pi over 4. Now I'm just going to use the unit circle. Cosine of pi over 3 is 1/2. Cosine of 3 pi over 4 is negative root 2 over 2, minus sine of pi over 3, which is root 3 over 2, and the sine of 3 pi over 4, which is root 2 over 2. That's a 2. And now I'm just going to multiply. So I've got negative root 2 over 4 minus root 6 over 4. And let me look at the answers. It looks like the answer is going to be D, and that's just because this root 6 is negative. Okay, moving on to number 2. All right, so number 2, I think I'm also going to use sum here. So let me go 3 pi over 12 plus 2 pi over 12. If I simplify those values, I'll get the tangent of, this is pi over 4 plus pi over 6. All right, so let me go tan plus tan, 1 minus tan, tan. So tangent of pi over, that's a 4, 4 plus the tangent of pi over 6 over 1 minus the tangent of pi over 4 times the tangent of pi over 6. Now I'm going to use the unit circle, and I'm going to work to the side here just because I don't have another choice. Normally I would work down on a piece of paper, but you know, we make do with what we have, space here. Okay, so the tangent of pi over 4 is 1, plus the tangent of pi over 6 is root 3 over 3. Hopefully you have that memorized. And then 1 minus the tangent of pi over 4 is 1, times the tangent of pi over 6 is root 3 over 3. All right, so I'm going to multiply both the numerator and the denominator by 3 over 3. Now remember, there's a parentheses around the entire numerator and the entire denominator. When I do that, I end up with 3 plus root 3 over 3 minus root 3. Now I can rationalize. Now remember, there are parentheses around the numerators and the denominators, so these are binomials that need to be FOILed. First, outer, inner, last. This is going to be 3 times 3 is 9. The outer and the inner are both 3 root 3, so that's plus 6 root 3, and plus root 3 times root 3 is just 3. In the denominator, we have each of these factors are exactly the same, but one is addition, one is subtraction, which means the middle terms will cancel. So we have 3 times 3 is 9, and then a minus, and then root 3 times root 3 is 3. So I'm running out of room here. Okay, so I just rewrote where we were at here. 9 plus 3 is 12, so that's plus 6 root 3 over 6. And now we're just going to simplify. So 6 goes into 12 twice. 6 goes into 6 one time. So this is 2 plus root 3. And that answer is, I think it was D. Yes. Moving on to number 3. So we take a look here. It says use the double angle or the half identity to find the exact value of this expression. Cosine of theta is 4/5. So cosine is positive, and we know it's between 270 and 360. So that's where I'm going to go ahead and draw my triangle and draw in my values here. The cosine is 4/5, which makes, using Pythagorean theorem, this value is going down, so it's going to be -3. Now it's asking us to find the sine of 2 theta. Well, this angle here is theta. So the sine of 2 theta, using the formula to sine theta cosine theta, we're just going to go ahead and write the 2. The sine of theta is going to be the opposite over the hypotenuse, so that's -3/5. And then the cosine is, we already know, is 4/5. And then we just multiply that out and we get -24/25, because that's like a 2/1. And there's our answer. Last question. Using the double angle or half identity, find the exact value expression. Okay, so tangent of pi/8. So I'm going to go ahead and use half because tangent of pi/8 is super small. So okay, so that means that theta would then be pi/4. Okay, so using the formula, and I'm just going to pick one of them. We've got 3 options, but I'm going to write the tangent of pi/8, okay, equals sine of theta, which theta is now pi/4, okay, because this is a half formula. So pi/4 plus, or sorry, 1 plus cosine of pi/4. All right, this should work. Let's see what happens. Sine of pi/4 is √2/2, and then 1 plus cosine of pi/4 is also √2/2. So I'm going to multiply the numerator and the denominator both by 2, which is going to end up with a √2/2 plus √2. Now I can go ahead and rationalize, and when I do so, it's 2 minus √2, 2 minus √2. Again, these are all parentheses around my numerators and my denominators. I'm going to have to distribute this √2, so that's going to be 2 √2 minus 2. And then I'm going to have to FOIL this out, but the outer and the inner terms should cancel, and I'll end up with 2 times 2 is 4, and then minus √2 times √2 is 2. So, simplifying that, if I factor out 2, I get √2 minus 1 over, erase, go away, there we go. Minus 1, there we go. The 4 minus 2 is 2. These 2's end up canceling. So our answer should be -√2 minus 1. And that's all. Peace out.